Okay, here we go. Well, Mike. Okay. So now we're going to talk about, this is actually a little bit of this we kind of did at the very beginning in the second chapter, but we maybe didn't look at it the same way. There, they considered the first part of what we're doing could be like examples of distributive property, but we're not going to look at it like that anymore. We're going to look at it like canceling common factors like we did in the classwork we did last time. So, right, simplifying fractions that include variable expressions, right? You're first going to have to find a least common denominator, if there is, for the numerator and for the denominator, right? Find the number that goes into everything, and sometimes it'll actually include a variable that goes into everything, right? So between these numbers here, right, this 36x, 24, and 6, what's the greatest common factor? 6, right? So let's factor a 6 from both the top and the bottom, right? So I'm going to go, this is going to be 6 times 6x minus 4, and then that's all over 6. Now again, when you're simplifying fractions, when is it that you're allowed to cancel something from the numerator and the denominator? When they're common factors, right? In this case, the 6 is multiplying times the rest of the numerator, and that 6, it is the whole denominator. Therefore, you can just cancel those two. So we're going to go cancel, cancel, and the answer is 6x minus 4. Now, fractions that include variable expressions are actually called rational expressions. So what is a rational number? A number that could be written as a fraction. So when you talk about rational expressions, it means basically fractions. Yeah. Because 6 is a common factor in 36 and 24. So just like we did in the homework from last night, that means you take the 6 outside parentheses, and then you divide each one of these by 6. 36x divided by 6, 6x. 24 divided by 6, negative 4. Okay. Well, when I'm figuring out what goes inside the parentheses, divide. So try that one. See if you could figure out what gets canceled on that one. That's good. So what do you think is the greatest common factor for all three of those numbers? 3. I mean, the truth is, if you're looking at the numerator only, 6 is the greatest common factor. But that's not going to help you cancel a 3 in the denominator. So we'll just take out the 3. Now, another question is, should I take out 3 or should I take out negative 3? If you notice what we did in that homework worksheet, I mean, usually if there's negatives involved in that first term, you take out the negative too. But you're not absolutely wrong if you didn't do that. Either way is okay. Like if you wrote it like 3 times negative 2y plus 6 divided by 3, or you could have wrote negative 3 times 2y minus 6 divided by 3. Right? And in the end, it doesn't make much difference. So we cancel the 3's. Negative 2y plus 6. So when we did this at the beginning of the year, again, it was seen to be something like an example of distributive property. They would have written it like this. Okay, that is 1/3 times negative 6y plus 18 and then distribute, that's 1/3 times negative 6y, and 1/3 times 18. If I can fit it in there. I mean, that's not, we will want to see this more as canceling common factors, because that's the issue. That's the thing that we make a lot of mistakes with going forward. Okay? So in this case, notice that we had 2 terms in the numerator and we had 1 term in the denominator. What do you call a polynomial that has 1 term? Monomial, right? What do you call if it has 2 terms? Binomial, right? So these can get way more complicated than this, but all we're really interested in is that we've got at least one of those, numerator and denominator is a monomial. It's 1 term. That's all we're really trying to get at here. Okay, how about this one? What would be the greatest common factor of all of those? 2. So let me factor a 2 out of the numerator, right? That'll be 2 times x minus 4. And then I'm going to show it like this, right? That is also 2 times negative 2. Okay, and so I've shown the common factor with that I'm now going to cancel. Cancel, cancel. So this is x minus 4 over negative 2, which you could write like this, negative 1/2 x plus 2. Right, the x over negative 2 is negative 1/2 x. The negative 4 over negative 2 is plus 2. What's that? You turn that equation into an equation that can be turned into a 1. Yeah, well, I mean, you could put that in the calculator anyways, right? Use the fraction format. So you don't really need to do it, but yeah, I mean, that would be considered simplified. That's not simplified. Yeah. Why would you not use what? Negative 4 is a common factor because negative 4 doesn't divide into 2. 2 divides into negative 4, but 4 doesn't divide into 2, right? Because it's bigger than 2. So you're going to look for the biggest number which divides into everything that you're looking at there. Okay, try this one. You took the negative 5 from negative 20, that left a positive 4. That was a positive 4, right? And now when you cancel the negative 5, then all that's left is 2z plus 4. That's it. What's the greatest common factor? Yeah, how about negative 5? I mean, if we can cancel the negatives, that'd be a good thing. So negative 5, what's left inside the parentheses? Get rid of that. 2z plus 4, right? 2z plus 4, and that's all divided by negative 5. So now we've got that common factor that we're looking for, and we cancel it. So the answer is 2z plus 4. Okay, now in these problems, in some of these problems anyways, the monomial, the 1 term, is actually in the numerator. So you wouldn't be able to use that distributive property thing for this anyways. Can you see what's the common factor between these two here? R, right? And there's not even any factoring to do, right? Because it's actually, there's only one term in the numerator and denominator. So we can just go straight away to cancel the R. And so what does that leave? What is the value then when you've taken away the R? Nope. 1/2. 1/2, right? The 2's in the denominator stays in the denominator, right? Okay, how about the one on the top right? It's already factored. So what's the common factor that could be canceled? 5. So cancel the 5. So cancel. So this whole thing is x over x plus 2. Now, can I cancel the x? No, you cannot cancel the x.
No,
the x is not a factor of the denominator. It's just one term, right? It doesn't multiply times everything else in the denominator. So you cannot do this kind of thing. That's simplified. Yeah. No. If it was, you mean in the numerator? 2x plus 2. Well, if it was x over 2x plus 2, you could definitely factor the 2 from those two terms. You'd have x over 2 times x plus 1, but you still wouldn't be able to cancel anything there. Okay. What's in common? 2m? I think there's something more than 2m. Yeah, it's actually, doesn't 6 divide into all three of those? And then what's the least number of m's in any of these terms? There's actually a squared. So the greatest common factor is going to be 6m squared. So let's take that out, right? In the numerator, 6m squared outside parentheses. What's left inside? M minus 2. Okay, what about in the denominator? If I factor this, 6m squared is one factor. What's the other factor? Times 3. So now we've written it in a factored form, and we could see that what's in common is 6m squared. So the answer is m minus 2 over 3. Okay, how about this one? Any common factors you'll be able to cancel? No, it's kind of like that one up there, right? You can't do the y's because that y is not multiplying times everything else. So that thing can't be factored. It's simplified. So done. Not factorable. Okay, here we go. So the important thing is you can only cancel when you have common factors in the numerator and denominator. You cannot cancel common terms. Right? Terms are what's separated by pluses and minuses. You can't just cancel one of those with something in the numerator. That's what to be careful of. So try these 4. One of them is not factorable. Which one is not factorable? Bottom left, right? There's nothing in common here. Can't do a C with a C, so that one you don't have to do anything on. How about, is there anything to factor here? 2a, 2a squared? Cubed, right? The least number of a's is 3, so they have that in common. So yeah, factor out 2a to the third from both of those. Right? That'll make it look like this. 2a to the third times 2 divided by 11. Oh, 2a to the third times 11a to the third. And then you cancel the common factor. So the answer is 2 over 11a to the third. What's it going to be? What can you see that you'd be able to cancel out on the top right? Edric, what you got? Well, if we take it as a to the third from a to the sixth, that leaves 3a's. I mean, remember, what do you do when you're multiplying the same base and they've got exponents? What do you do with the exponents? You add, right? So 3 plus 3 is 6. So no, when you factor it out 2a to the third, you should have 11a to the third. What's going to end up being the least common denominator here? And actually, that one doesn't have one either. In terms of simplifying that fraction, because there's no s here. You know, it's true, you could take out a 2s here, and you could take out a 3 there, but in the end, nothing's going to cancel. Yeah.
If the 12 had an S2, would the, like once you factor the S out, would you add the 3 and the 12?
If this was 12s squared?
No, if it was
12s? Well, then you could combine my terms. 3s plus 12s. But yeah, I mean, there's nothing that divides into all four of those terms. So you're not going to simplify this fraction. So actually there was 2. Okay, what about that one? 8x. So we could have done something about that 8x. Right, that'll be 8x divided by, what's in the denominator, if I take out an 8x, what's left? X squared plus 2x. Okay. Okay. So then we can cancel. 8x cancels with 8x. What does that leave? I think Callie said x squared plus 2x. That's not quite right. If I cancel the 8x's, what's left? 1 over, right? 1 over x squared plus 2x. That's a common mistake. So if it's in the denominator, it needs to stay in the denominator. So these two were not factorable. Not factorable. Not factorable. Okay, that's the homework.